Hey everyone, happy Wednesday. As you know, it's Math Wednesdays with the Learning Liaison. I am your star host, Miss Pryia. I hope you had a wonderful time since I've last seen you. The last time I saw you, I got married. From then, there was Halloween. That's really pretty much it, just Halloween. Not much has gone on for me either, but as always, you guys know how much I love math, so, oh yeah, I went to this Harry Potter experience thing. That was fun. Okay, so I did something exciting. But other than that, let's go ahead and jump into math. As always, you know that I love to read your comments in the chat, so you are more than welcome to put it in there. I've got it up, so I will always see it, all right? So question 1, it is a number sense question. Definitely elementary / middle school type of question, right? Well, it doesn't look like it's got much going on, which is great because normally words scares everybody. It's kind of like one of those things where you see words and you just get terrified and you don't know what to do. And we're getting better at that, right? I hope everyone's nodding yes. Yes, we're getting better. Words aren't that bad, right? And in math, they're really not that bad. It's just a lot of information that you have to sift through. So here we have some words, nothing too bad. And it says, if you were to place the numbers below in ascending order, you have to know what that means, which would be the second number. So you actually have to place them in order to figure out what is going on. And then you have to know what ascending means. So in the chat, go ahead, tell me what the word ascending means. And you can use greatest to smallest, smallest to largest, anything that makes sense to you. Tell me in your words what ascending means. And I'm really hoping you guys are saying the same thing I just wrote, least to greatest. So it means it is ascending. It is getting larger. The opposite of ascending would be descending, which means you start from the largest and you descend, you go downwards. Think of ascending on an airplane and descending on an airplane, right? That taking these words and putting that back into normal life really helps you get through these problems, I promise. And then they didn't just ask for a number or for you to put it in order, they then asked for the second number itself. So let's go ahead and figure out what's going on here. So right now we have 33%, we have the square root of 169, we have a fraction, 1/3, and then we have this thing over here. It says 13 and 76 thousandths times 10 to the negative 1. A lot of you are probably looking at that going, I don't know what that is. That's okay. Well, first things first, we cannot compare these numbers because they are not the same. They all are numbers, yes, but they're not in the same form. So how can we change them? We can put them all into decimals. So it will either have a whole number in a decimal or a decimal by itself. It's just one of those things that it just makes it easier, right? I'm not trying to change everything into square roots or change the fractions, everything into fractions. I'm not trying to do any of that. I'm trying to make my life easy. So remember, percent sounds like cents, money, right? Like money. Or it means per every 100. So for every 100. I have 33 cents. So if I had 33 cents, that would be 0.33. Use your calculator to figure out what the square root of 169 is. Let's say on your calculator, you don't have that lovely square root button. It's all right. I can help you figure that out. Ready? If 169, okay, so we think not if, let's think of it. Is 169 larger than 144? Yes, it is. I know that the square root of 144 is equal to 12. How do I know that? I know that 12 squared, or 12 times 12, is what comes out or makes the product of 144. When you put that square root sign, what's happening is you are developing these two 12s and one of them can come out. So the square root of 144 is 12. So if I'm already at 144 for 12, I'm going to try 13. It just so happens that 13 times 13 is 169. So 169 is a perfect square, and it is 13. So I go and I use my calculator for the fraction as well. I type 1 divided by 3, and the calculator tells me it's 0.333, and it just keeps going, right? So I'm going to put 0.33 repeating. The bar means repeating. So if you ever see a bar, let's just side note quick. Let's say it said 3, 1, 5, and the bar was over the 1 and the 5. It means that the 1 and the 5 keep going. All right, so that's something good to always know. Little things always help make a big picture. All right, so now we're at this lovely 13 and 76 thousandths, and you guys are staring at it going, well, I don't know what to do with that. Does anybody by chance know what form this is in? What form is 13 and 76 thousandths times 10 to the negative 1? I'll give you a hint, starts with an S. It's scientific notation. I hope I spelled that right. I'm not an English teacher. It's not for me. So it's scientific notation. How do I know that it's scientific notation? Scientific notation tells me that I need the number times 10 to an exponent, which is really cool because the only two things I need from all of this is that number that I underlined and that exponent that I circled. All right. So what do? I write the decimal number that they give me. So the number in front of the times, that's not an X, that's a multiplication. I write it down. So I have 13 and 76 hundredths. So now we're going to use some technical terms. That negative 1 tells me I need to make a swoopy to the left. Why to the left? Because if I'm here, right, here's me, I'm 0. Positive numbers go to my right, this is the right, and negative numbers go to the left. So if that was a positive number, I would make a swoopy to the right. And because it's a negative number, I'm going to make a swoopy to the left. All right, technical term for the day is swoopy. So now my number is 1 and 376 thousandths. I've been making a promise to myself that I'm going to not cheat on how to say the decimals anymore unless they're really ridiculous, just to help you guys out, all right? So I have 1.376, or the technical term is 1 and 376 thousandths. Okay, now what do I do? Remember we talked about this earlier. We had to figure something out. We need the second number. Well, I don't know what the second number is because I haven't put the numbers in order, all right? So let's go through our list and let's see what comes first. So we have 0.33 or 33 hundredths, and we have 0.33 repeating. Which one's smaller? So a lot of you may be staring at this going, well, I don't really know how to tell the difference. Remember, we talked about it earlier. That 3 with that bar means repeating. So by default, I have 0.33, let's give it one more place, 3. So now if I'm just looking at anything after the decimal, that's 333. And over here, I only have 33. So which number is larger? The 333 is definitely larger than just 33. So if I had to put it in ascending order, I'd say that the 33 is my first. This will definitely be my second. Now I'm kind of left with 13 and 1. So 13 will be my, 13 will be my last one. So 1 will be my third, and this one will be my fourth. And remember, when you're putting them in ascending or descending order, they don't give them to you in the form that you changed it into. It's always the form that they gave you. So let's go ahead and write this out just so we can see it. 33%, 1/3, Then we have scientific notation, 13 and 76/100 times 10 to the negative 1, and square root of 169. Remember what the question says. The second number. And we established that earlier, 1/3. Allergy season. All right, any questions? 1/3. All right, and the great thing about this is, let's say they asked for something else down the line and they gave you 2 questions that were pretty much the same, and they asked for like the third or the fourth. Well, you already know how to put it in order. So at this point, it's just picking and choosing what you need from it exactly. All right, you know what to do. Ask a question in the comments, and we can always come back if you haven't. Question number 2. You know it's my favorite. It's algebra. And here they're asking us to use the equation below to determine the number of roots. When we hear that, things should be going off in our mind and kind of telling us what we need to do in order to solve for the problem. So I'm going to give you a second before I start writing. What are those thoughts that come to your mind when they ask you to solve for the number of roots? Number of roots. How do you do it? Number of roots. What are we looking for? Starts with a D. There's something that's going to help us. It is called the discriminant. The discriminant can be found from what equation or formula? It's from the quadratic formula. All right, bear with me. When I was in high school, my teacher made us learn the song or learn a song in order to be able to write out the quadratic formula. I cannot write it without singing it. My singing is not good, so you guys are in for a treat. It is, here, let's write it off to the side, the quadratic formula. It is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. And that is the quadratic formula. So from the quadratic formula, where is our discriminant? Right there, it's right there. It's the thing under the square root. So we actually have to use b squared minus 4ac in order to figure out the number of roots. And then there's like a term and condition that comes with this, right? So not only do you need to know that you need to figure out the discriminant, you also need to be able to use it. And when I say use it, what do I mean by that? I mean that once you get a number, there are things that now happen. So let's talk about that. If the discriminant is larger than 0, how many roots are there? 2 real roots. If the discriminant is equal to 0, how many roots are there? 1. That fancy R just means real. There's 1 real root. Now, if the discriminant is less than 0, how many real roots are there? There are 0 real roots. That means that there are how many imaginary roots? There are 2 imaginary roots. Okay, so let's think about that really quick before we move forward. Think about any number less than 0. What type of number is that? Negative. You should be yelling negative. It's a negative number. Yes, it's a negative number. Any negative number under a square root Is that a real number? Does it produce a real number? No, it does not, because that negative has to come out and create an imaginary number, right? So if we just think about what we have, we can kind of figure out what's going on, right? So let's move forward from where we are and let's go ahead and use now what we know to be better and solve the problem. So we start with what we have. X squared plus 8x equals -7. Well, I can't really use what I need to based on this. And then, we need an A, B, and a C. And the A, B, and C will come to us once I keep moving forward because it has to technically be in another form. Well, everything has to be on the same side in order for this to work. So let's go ahead and add 7 to both sides. So we'll have x squared plus 8x plus 7 is equal to 0. Now here's where we get our A, B's, and C's. X squared plus bx plus c is equal to 0. And if we're using that as our model, then our a is equal to 1, our b is equal to 8, and our c is equal to 7. All right, now all I have to do is plug it into the formula that we talked about for the discriminant, that lovely guy up there. So I'm going to write it out and then plug it in. So b squared minus 4ac. So b is 8, 8 squared minus 4 times 1 times 7. So 8 squared gives us 64, minus 4 times 7, -4, or 4 times 7, keep the negative sign, that is there, 28. And 64 minus 28 is equal to a positive number of 36. 36 is not our answer. 36 is what helps us understand what our answer will be. So remember, we talked about the terms and conditions earlier. 36 is a positive number. So if 36 is a positive number, we have 2 real roots. C, winner, winner, chicken dinner. Questions. So this may have seemed like a very easy problem, but the thing behind the easiness of this problem was you had to know a lot of background information. You could, yes, sit and solve for your x values and see how many real numbers you get. That is another way to do this. But the quicker way is to go ahead and just do it this way, right? And it's funny that I say you can go ahead and solve and get the actual roots, because my bonus question today is, what are the roots from the problem before? So we have x squared plus 8x, I'm going to write the plus 7 equal to 0. So we can do this one of two ways, right? We can factor it, which we will, and then we can use the quadratic formula. So we're actually going to do this twice. I know, it's such a cool problem. One problem you can do so many things with. All right, so here when we're factoring, we look at all the numbers and we say there's nothing that we can technically take out to make this any easier. So now we do our regular factor. You start with 2 sets of parentheses and my x's, and I go, what are my factors of 7 that add or subtract to make 8? Well, 7 is one of those numbers, you only have 1 and 7. So it has to be 1 and 7. And I can't subtract them, both of them. I cannot have a -1 and a -7 because I'd have a -8. So they both have to be positive. And you can always FOIL, right? You can always do x times x and x times 7 and 1 times x and 1 times 7 in order to see if your factoring is correct and it gives you back the original equation. So here we're not done. We haven't figured out our roots yet. We just factored what's going on. So now what we need to do, go ahead and set each of them equal to 0. All right, this will now help us actually figure out what our x-intercepts are, which are our roots, which are also known as zeros. I know, a lot of words for the same thing. So you go ahead and solve this like you would any regular problem, and x would be equal to -1. You subtract 7 to both sides, and x would be equal to -7. Those are your actual roots, and they just so happen to both be a real number, and that's the answer we got before. So let's say you can't factor, like factoring seems to be like its own problem. You can use the quadratic equation, right? And these are all different ways to solve the same problem and help you understand what's going on. So if one way and one approach doesn't work for you, there are other ways to do it. So here we go again. X equals -b plus or minus square root b squared minus 4ac divided by 2a. All right, here's our quadratic equation. I have all of my pieces that I need because it's in the correct order. X squared, then x, then just my constant. So my a is 1, my b is 8, and my c is 7. Plug them all in. -7 plus or minus the square root of 8 squared minus 4 times 1 times 7 all over 2 times 1, which is 2. And we're going to cheat a little bit because we earlier found out the discriminant is 36. So I'm going to put that in. So I have -7 plus or minus the square root of 36 all over 2. And what is the square root of 36? Anybody? 6. -7 plus or minus 6 all over 2. Okay, so the thing here is you might get this answer and you might say, well, I only have one solution, so what happened? Well, nothing happened. You just have to make sure that you know what to do with this plus or minus. That plus or minus tells you that it's a +6 and it's a -6 or a subtract 6, right? So you have to write it twice. You just don't get away with writing it like that. So we have some more work to do. So here, now we have -7 plus 6 all over 2 and -7 minus 6 all over 2. -7 plus 6 is -1 all over 2. Did I do something wrong? It's not 7, it's 8. You guys aren't even yelling at me like you normally do. Okay, I did this wrong. I'm gonna erase what I need to. Then I'm gonna change the color. So I'm gonna put the corrections in red. That's supposed to be a B, not a C. I apologize. It was like the numbers don't make sense. Okay, so if you don't do the mistake that I did, you'll be fine. So now what we get is -8 plus 6. Let's just rewrite that. Be safe, I'm sorry. -8 plus 6 is -2, and -2 divided by 2 is -1. And over here, we add a -8. And -8 minus 6 is a -14 all over 2. And -14 divided by 2 is -7. And look at that. We have the exact same two answers from the last one because I changed it and I fixed the mistake. Okay, so these are just different ways to do the exact same thing, like I talked about earlier, right? So you just want to make sure that whatever you're comfortable with is what you're using. It would be great to factor instead of using the quadratic, because look, the quadratic does take a little bit more time. But if factoring like the way that we did on the left-hand side is not something for you, then maybe the quadratic, so you have a foolproof way to do it, is a better option, right? Question number 3. I was in a geometry kind of mood when I made this one. So it tells us that that thing means angle. Angle EDC and angle UJM are congruent measures. Well, you know what I'm going to ask you. What does congruent mean? It means equal. Oh yeah, I totally heard you. It means equal. So if something is congruent, it means that it's equal. It's exactly the same. So if I had a twin sister, which I don't, we would be exactly the same, right? So now what they're telling us is if M, so the measure of angle EDC is equal to 86 degrees, and the measure of angle UJM is equal to 4.6, I meant 4.7, 4 and 7 tenths x minus 6, 4 and 7 tenths x minus 6, which is an equation that can be used to find the value of x. I know I said I was going to be better, and I'm not doing much better today. So we know this, and we know this. And we know that big information that they told us earlier about them being congruent. So if they're congruent, what is another way to write something that is equal to each other? To literally set them equal to each other. So if I had to set them equal to each other, I can put that the measure of angle EDC is equal to the measure of angle UJM. And now I can plug in what I know about them. I can say 86 degrees is equal to 4 and 7 tenths x minus 6 degrees. So now we're just looking for that as an answer choice. It's definitely not A, B, or D. So our answer choice here is C. Winner, winner, chicken dinner, right? And I would never just ask you such a nice question without throwing a loop at you. I don't know if I wrote it on the second page. Okay, I didn't. And say, well, what if they asked you for the value of x? Well, you'd have to come up with this equation without knowing if you're right or wrong. And then you would have to take the equation and actually solve. I know, it's a crazy concept. So in order to solve, we actually can't do anything with the parentheses. So I'm going to just remove them. Make it a little bit easier on the eyes. And then remember, we want to solve for x by itself. So you need to move the 6. If it's being subtracted, you have to add it. So we'll have 92 is equal to 4 and 7 tenths x. Remember, x needs to be completely by itself. So the last thing we need to do is to divide by 4.7. 4 and 7 tenths. X is equal to what, everyone? Does anybody have it? 19 and 57 hundredths. Boom. 19 and 57 hundredths. Just in case they asked you for x. And you can check your work by simply taking x and plugging back in, right? All right. Ask questions if you need to. So here is a trig question. And the thing about this trig question is I didn't give you any answers. I didn't give you any answers on purpose because some questions on some of the tests that are out there actually don't always have answer choices, right? They don't make it that easy for you. So I tried to make this one a little bit more difficult. And in order to do that, I kind of just asked you 3 things, A, B, and C, and I gave you a little bit of a scenario beforehand, right? So question 4 reads, given that theta, that's theta, given that theta is an acute angle measured in radians, sometimes it's good to know, if you're using a calculator, you're definitely going to want to know what you need to put it in, right? If the angle theta is acute, it's an acute angle and it's measured in radians, and that cosine of theta is equal to k, find in terms of k an expression for the following. So they kind of told us something, and you can stare at the problem and go, well, what am I supposed to do with that, right? You're sitting here and you're looking, okay, well, cosine of theta is k. Great. Now what? All right, well, I can tell you now what, I promise. There's this really cool trick that I learned that I always kind of end up using every time I see sine, cosine, and stuff like that, right? So it's called SOHCAHTOA. So I'm going to write the abbreviated version of it. This is how the SOHCAHTOA comes. SOHCAHTOA, right? And what it translates into is sine of whatever it is equal to the opposite over the hypotenuse, right? And then we have cosine of whatever it is equal to the adjacent over the hypotenuse. And then we have tangent of whatever it is. And I say whatever it is because it could be x, it could be theta, it could be y, it could be z, it can be elemental p, it can be anything, right? So I just leave it open for interpretation. And that is the opposite over the adjacent. Okay? So now that we know more about what's going on, we can use this to help us figure out what cosine's trying to tell us. So based on cosine, what do I know? Well, I know cosine of theta is equal to k. Well, anything not over a number is over what? Over 1. So cosine of theta is equal to k over 1. And remember earlier we said that it's the adjacent over the hypotenuse. So ADJ over HYP. The adjacent and hypotenuse of what? Of a right triangle. So if I had to draw this out, it would look something like this. There's my right triangle. I'm going to put my theta right there. The opposite side is here. The adjacent side is here because it's opposite of the angle. The adjacent would be next to the angle, and the hypotenuse always stays as the hypotenuse. So we never have to worry about that, right? So if theta, for whatever reason, was up here, which it might be, then this guy down here would be the opposite, and this guy over here would be the adjacent, right? And I wrote that in green so you don't mix them up. But I'm going to erase them because I would hate for people to get them mixed up. Okay, so we have what we know. Now let's plug in the numbers and letters based on what we established, right? So if that's cosine of theta, the adjacent is here, which is k, and the hypotenuse is here, which is 1. So now we go, okay, well, that's all I can possibly figure out based on what they told me. Now let's go to the question. A is asking us for sine of theta. Remember earlier, we said sine is equal to what? The opposite over the hypotenuse. Well, I look at what I have and I actually don't have the opposite. So we actually have to solve for that. In order to solve for that, how do you solve for any side or leg of a right triangle? I think I can hear you if you say it a little bit louder. Pythagorean's theorem, a squared plus b squared equals c squared. Right? Okay, so let's plug in what we know. Well, I know a squared, let's call it k. So k squared, I do not know b, so I'm going to leave it b. And I know my hypotenuse is 1. So I'm going to solve using this. So I'm still going to keep k squared, keep my b squared, and my 1 squared turns into 1. So now there's nothing else to do. I just have to move some stuff around to figure it all out. So minus k squared on both sides. And we get b squared is equal to 1 minus k squared. Okay, but that's not really going to help us because we need b by itself. It's not b squared. So we have to take the square root of both sides. So b is equal to the square root of 1 minus k squared, which so happens to be the opposite side that we were looking for, right? So now we can plug in what we know. It is the square root of 1 minus k squared. So sine of theta, I'll write it down here. Sine of theta is equal to 1 minus k, square root of 1 minus k squared over 1. Or it's the same as saying just square root of 1 minus k squared. And that's A. We still have B and C. So I keep the triangle because it's the same stuff, right? We're using the same information for the rest of this. So now B is talking about tangent. tangent of theta. Remember earlier we said tangent of theta is opposite over the adjacent. So my opposite, so my tangent of theta is equal to my opposite, which is 1 minus k squared, all over my adjacent, which is k. And that, after doing all the work before, is the answer. Okay, so how are we going to do the next guy? I'm going to take the next guy over to the next page. So the next one is C, and C is cosine of pi minus theta. I'm going to redraw our triangle really quick. We have our theta, we have our 1, our k, and our 1 minus k squared. Okay, so here we go. About pi minus theta, and they told us in radians, right? So if you know something called the unit circle, you can get through this. And if you don't know what the unit circle is, you kind of need to just know what pi, well, cosine of pi is. And cosine of pi is actually 1, negative 1, negative 1, negative 1. So what's happening right now is what? If we looked at a graph, this would be 0, this would be half of pi, and this would be pi, right? And if I'm at pi, it's telling me now to subtract whatever theta is. So if I subtracted theta, I don't know what it is, I'm just going to draw a line anywhere. That line would be my pi minus theta, which is important because now we know the quadrant that cosine pi minus theta is in. And that's quadrant what? 2. It's helpful because that now tells us that cosine is no longer positive. Cosine is what? Cosine is now negative. So now we go from cosine pi minus theta to knowing that we have a negative cosine of theta. Okay, so based on what we know, we did the pi minus theta, and we can't just get rid of the whole theta thing. We still have to write cosine of something. We can't just write negative cosine, because then we wouldn't be able to finish solving the problem. So we have negative cosine of theta. Okay, well, last thing, cosine of theta is what? Remember earlier we said that it was k, they actually gave it to us. So our answer here is negative k because of pi minus theta. So cosine pi minus theta is actually negative k. Yay! All right, number 5. Number 5 is another trigonometry problem. I know, you guys might not like them, but I really do. I don't know what it is. Once I get into trig, those complicated maths and a little bit more advanced stuff, it really gets me going. I really want to throw that stuff at you guys in a nice way, not a bad way, right? So we look at the problem and it tells us to just solve. And they give us this lovely equation, but they don't really tell us much about it. They just tell us to solve the equation cosine of negative 1 or inverse cosine times, or inverse cosine of x, 8x to the 4th plus 10x squared minus 16 is equal to pi. So you're staring at this and you're going, okay, what am I supposed to do with that? I don't know. I don't know. Does anybody have any ideas of what to do here? I know. We don't really want that inverse cosine, okay? I'll give you a hint. How do we now move this guy to get rid of him, essentially, or move him? I don't mean to get rid of him, but we don't want him on the side that he's on. So let's move him. So if we moved him, it's just like saying we have x to the negative 1. To move it or rewrite it, it would turn into what? 1 over x. And if you had to move it across an equal sign, I'll put 7 there. If you have to move it across an equal sign, what are you doing? You are now multiplying. You're doing like the opposite, the inverse of it, right? And we'll get 1 is equal to 7x, right? So here it's the same thing. So I'll write it in cosine terms so you understand a little bit more. So we have cosine of -1 is equal to this mess. We'll call it just x, and we'll leave pi, right? So cosine of -1 can be rewritten as cosine in the denominator, right? Well, cosine in the denominator, if we need to move it over to the other side, we now multiply it, right? Cosine and cosine. So when we do that, we get rid of the cosine -1 that's there, the inverse cosine, and we now multiply pi by cosine. And that is the step that I'm about to do. So I just wanted to show you how it works before I actually do it. So I'm going to move him over to the other side. So I'll now have 8x to the 4th plus 10x squared minus 16 is equal to cosine of pi, because I moved cosine to the other side, right? Well, cosine of pi is what? Does anybody know? I said it earlier. Were you paying attention? Does anybody know what cosine? Don't use calculator. I said it earlier. What is it? What is cosine of pi? I should hear you screaming. -1. It's -1. Okay, so I have -1. Because cosine of pi is -1. Right, but that doesn't make it any easier because I still don't know what's going on. So you have a couple of options here. You can take your x's and plug them in, figure it out that way, or you can keep solving, right? In order to solve, we don't want that -1 over there. We want to make sure that everything is together. So now we have 8x to the 4th plus 10x squared minus 15. Right, so remember we said we have two options here. We can plug them in, figure it out, or we can keep solving. I'm going to keep solving because I know you know how to plug things in, right? So let's try using another method. Another method would be, well, we can't factor these because we have x to the 4th power and x squared. So what we would need to do is use a u substitution. And let's make our u equal to x squared. So if I made my u equal to x squared, I now have 8u squared plus 10u minus 15. That is now definitely something I can factor. That's not a very pretty factor. So remember earlier we talked about that quadratic formula? We're definitely going to have to use it here. I'm going to sing in my head. It's probably not as fun if I sing it in my head. I just realized that. Sorry, guys. Next time I'll sing it out loud. Okay, so the thing about that is I put x is equal to it, right? Because that is the standard formula. But just now we just used a u substitution. So I'm not going to use x. I'm actually going to use u because I'm solving for u in this case, right? But remember the original problem has x's in it. So let's keep moving forward. So now I'm going to plug in what I know. I know that my A is 8, my B is 10, and my C is -15. I plug it all in, and I get this. U is equal to -10 plus or minus the square root of 10 squared minus 4 times 8 times -15 all over 2 times 8. And I think I did the wrong numbers, did I? No. Oh, I'm just in the wrong problem. Okay, I don't have the math for this, so we're about to see if Pryia can actually do math. Yep, I have no calculator. All right, guys, we're getting ready to do this. Oh, if u is equal to x squared, what about the 8x to the 4th? So x to the 4th. Okay, let's talk about that. That's a great question. So x to the 4th. It can be rewritten as x squared times x squared, right? And for every x squared, we can place a u. So we'll have u times u. So by default, our x to the 4th now turns into u squared. Does that help? I'm going to move that, but keep it. So that was a really great question. We're going to keep it over here. All right, so I'm going to box that off so we don't have to get rid of it. That is a great question. I'm going to need somebody for a calculator because I, off the top of my head, do not know what 15 times 8 times 4 is. Okay, so we have u is equal to negative 10 plus or minus the square root of 100 because 10 squared is 100. How are we going to do this? 15 times 8. Put my 0, carry my 4, 8, 9, 10, 11, 12. Yes, this is how. Oh, no. Okay, this is how I do math. 8, 9, 10, 11, 12, 120. 120 times 4. 4 and 12 is 48. This is a positive, so 480. Ooh, I don't know the square root of that. And 8 times 2 is 16. Oh no, that means my answers might be wrong. Because I typed a different problem than I wrote on my paper. But it's okay, we're going to get through this. So my answer choices no longer work. But let's keep going. So we'll have u is equal to negative 10 plus or minus square root of 580 over 16. I'm going to take that to the next page. U is equal to negative 10 plus or minus square root 580 over 16. So 580, I'm going to make my tree. It is not going to be a pretty tree. 580. I have 2. Half of 500 is 250. 250, half of 80 is 40, so I have 290. And 290 divided by 3. 7, 8, 9, 20. No, that doesn't work. 10. So 10 and 29. And 10 gets broken down into 5 and 2, and 29 cannot be broken down. So we take out the 2's, okay? And 29 times 5 is 5, carry the 4, 10, 14. Okay, so when we simplify our square root of 580, I did a lot of math off to the side. What I did was, I didn't have a calculator. I have no idea what my calculator is, and my paper does not reflect the answer. So I did my little tree. I do my tree because I need to see how many groups, how many pairs, right? Because it's square root, so how many 2's, not the number 2, how many numbers can be paired to be taken out of the square root to simplify. And I found that I break it down, and I have 2 2's, so I take out a 2. And inside, I'm left with a 5 and a 29. So I now have to multiply the 5 and 29 in order to figure out what stays in the square root. And 5 times 29 is 145, according to my math. And I keep my plus or minus, my negative 10, and my 16. So now the thing about my answer choices is, remember I said they no longer make any sense? They don't, because this is not a pretty number. So what ends up happening is, remember we talked about u earlier, and way before we had a problem with a plus or minus? Well, we by default have to rewrite this as 2 problems. So we still have u is equal to negative 10 plus 2 square root of 145 over 16. And we have u is equal to negative 10 minus 2 square root of 145 all over 16. Remember I talked about it earlier. It's right here. I wrote it down for us. U is what we subbed for x. And u is what? U is x squared. So now we have to actually use our x squared. It's just not pretty, but it ends up working, right? So x squared is equal to negative 10 plus 2 square root of 145 all over 16. And x squared is equal to negative 10 minus 2 square root of 145 all over 16. But we don't want x squares. We never want x squares. So how do we do this? We take the square root of everything. I know you guys are probably like, what are you doing? I'm losing my mind, just like you. So we now have x is equal to the square root of negative 10 plus 2 square root of 145 all over 16. So you can take, I'll show you off to the side. You can take the square root of the numerator and the denominator separately in order to help, which it'll help a little bit in this case because we do have 16 in the denominator and 16 is a perfect square, right? So, side note, if I was to take the square root of the first one, take the denominator and the bottom, I would do square root of negative 10 plus 2 square root of 145. That's not pretty, but kind of ends up happening that way. And the square root of 16 would give me 4. So I would keep my negatives like this. I keep everything else the same. I can write 4 in the denominator. And then what you can do is you can even take it a little bit further if you wanted to and do this, which is not pretty because we end up having a negative 10, and negative 10 under a square root is an imaginary number. And like I said earlier, just didn't work out because my numbers didn't work out. But if you follow the same process, and instead of having 10x squared, you have, I think it's supposed to be 14. The problem will work, and your answer, I will tell you what the answer is. The answer is B, all right? So it only doesn't work because I accidentally made a big boo-boo on my numbers. But following the same process, you're going to get a result that's actually on here. So you notice that the x to the fourth and the x squared were not able to help us factor. So that's where we needed that u substitution. And a lot of you are probably staring at the screen going, I don't know what a u substitution is. We kind of do it all the time, right? We take things that make things easier for us and we substitute them out for something smaller. And we notice that the u can be x squared. Then you do your math using a quadratic formula. And then when you get down to your two separate pieces, you have to remember that u is equal to that stuff, right? So our u here is actually x squared because remember, we u subbed them earlier. So we have to plug them back in to solve for x because essentially that is what we are solving for, right? So just keep in mind, it does get easier if you use the numbers that you're supposed to and not the crazy numbers that I used instead. Okay. Last problem, it should be a quick one. I won't do it 2 ways. I'll only do it one. Save us all the time on this. But it's telling us to solve, well, we're just finding the limit of something. And they gave us the equation. When we are finding the limit of anything, it is a calculus problem. This is a high school college level problem. And the great thing about the problem that I created is I told you that x is equal to 4. We love that. Why do we love that? Because it's simply a plug and chug. I do not need to expand this. And if you chose to expand the numerator, you will find that you get the exact same answer that we are about to get together. So here I'm going to plug my x value in to the equation, the thing that they gave me. So I have 2x, so I'm going to put 4. And then I have all times 4 minus 1 squared all over 4 times 4 squared plus 5 times 4 minus 8. Okay, now I'm going to do it. 2 times 4 is 8. Then I'm going to do my parentheses. So 4 minus 1 is 3 squared all over 4 squared is 16 plus 20 minus 8. And then 3 squared is 9, so 8 times 9 in the numerator. And 4 times 16 is, I don't know, I didn't write it down. 16 times 4 is 64. Plus 20 minus 8. Then my numerator is going to yield 8 times 9. I'll write it in a straight line, 72. And my denominator gives me 76. That is reducible. So I normally choose to do the 6, not the 6. I normally choose to do 2 because that's just an easy number, right? They both end in an even number, so 2 just seems easy. And if I divide it both by 2, I get 36 and 38. Great thing about that is it's still an easy number to divide by 2 again. And I'll get 18 and 19. It doesn't seem so bad, right? It's not. It's really easy. When they give you a value for x and you have the limit, all you have to do is plug it in. I promise. Calculus is not always difficult. Okay, so we're not going to do the last problem because we're kind of running a little low on time. There's 2 more problems. So what I am going to do is thank you because, I always love having you guys here. Oh, okay, I'm going back. I'm sorry. You are right. Okay, thank you. I'm trying to erase it. I made a big fat boo-boo. 36 is not 36 over 36, it's 36 over 38, which reduces to 18 over 19. Thank you, thank you. Okay, now my big fat thank you to everybody for coming and everybody for watching, right? Learning Liaison loves to help teachers and we're always going to be here for you. We have online tutoring options. You just have to look out for what we have. We have our courses, we have our boot camps, we have all those great things, right? And it's always there. So go check it out. Check back in next Wednesday. It might be me, it might be Amy, who knows? All right. Everybody have a great day and until next time.